I don't even know why this is a question sometimes, but lots of teachers will ask you to draw all the isomers of C6H14. The first thing I'm going to do is just lay out a 6-carbon chain. 6 carbons, that's the C6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 hydrogens. This is the first isomer of C6H14. Now we need to be able to create other isomers here. We need to be able to break this chain and reattach it in some way that it's still 6 carbons, and we still have 14 hydrogens, but it's not arranged in quite this way. The way that I like to do that is step by step. What's the shortest chain that I could cut off of here? Well, that's having 1 carbon. So let's cut that 1 carbon off. I now have a 5-carbon chain, but I have to reattach it somewhere. I can't reattach it to this carbon because it was already on that carbon and then it's the exact same molecule. I can't reattach it to this carbon because then I've just created another 6-carbon chain, and that's exactly what I had before as well. One of the isomers has the carbon sticking out here. And notice the number of hydrogens: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's still C6H14. But I could have also jammed that carbon onto the middle of the 5. This is also distinct from the others in that this is a 6-carbon chain, this is a 5-carbon chain with 1 sticking out of the 2nd carbon, this is a 5-carbon chain with 1 sticking out of the 3rd carbon. 3 hydrogens, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Beautiful. So that's what we can do with a single carbon that we chopped off the end. What if we chopped 2 carbons off the end? We end up with a 4-carbon chain, and we need to create, or we need to reattach those 2 carbons somewhere along here. Well, the first way that I can see is to attach 1 here and 1 here. The longest chain here is still 4 long, but I have 2 methyl groups sticking out of it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Beautiful. Oh, I didn't attach it there like I should have. One other place we could try to attach this is maybe attaching it to one of the middle carbons. Again, we can't attach it to the end carbon because then we're just right back where we started here. But the issue here is you have 1, 2, 3, 4, 5 carbon chains with 1 sticking out of the middle. This is exactly the same as this, so that's not unique. Honestly, I can't think of any other isomers beyond splitting the 2 apart and attaching them to the middle. Because again, if one of them gets attached to the end, I now have a 5-carbon chain, and we've already taken care of all the 5-carbon chains. The last thing is maybe we could cut off 3. I don't know if this is going to work. Oh, hello. I botched that. There's another way to attach these together. You could have a 4-carbon chain and put both of those ones that you chopped off the end onto the same carbon. I would have been remiss to ignore that one. Again, the longest carbon chain you'll find here is 4 long, and the 2 carbons are attached to the same single one in the center. Alright, last chance here. Let's see what we can do with a 3-carbon chain. What could I do to add 3 carbons to this that's going to allow me to say that that molecule is different from all the others? I can't just attach them here as a chain of 3 because then I have a chain of 5 and I already took care of all the 5s. I can't put 1 here, 1 here, 1 here because then I have a chain of 4 and I already took care of those. I don't think I can do anything with that. I think these are the only isomers of C6H4. Let's name them while we're here. This is just called N-hexane. It's 6 long. Actually, most people just call it hexane. I call it N because it's just normal. There are 2 names for it. This is a pentane because it's 5 carbons long, but there's a methyl group sticking out of the 2nd carbon. which means it's 2-methylpentane. Similarly, this is a pentane, but it has a methyl sticking out of the third one. That's 3-methylpentane. This, the longest chain I can find, is a butane. It's 4 long. And I have methyls sticking out of the second and third carbons, which makes it a 2,3-dimethylbutane. All one word. And this one, similarly, is a 2,2-dimethylbutane. I challenge you to find a propane that has the formula C6H14. But who knows? If you can find another isomer, post it in the comments, but I'm Chemist Nate, and I'm pretty sure this is it. Hey, best of luck to you.